Hey, have you seen the Wayanad news?
Yes, it's insane.
Yeah, looks like the NDR team has tried so hard to rescue a lot of them.
It's day 6, but it still seems there are a lot of victims who aren't rescued.
Yeah, that's true, but I wish there was an efficient solution for this.
Every life matters and every second counts. We introduce you to our innovation VL360, an effective AI-powered victim locator.
VL360 is an effective AI-powered victim rescuer.
It is a feasible GPR, also known as ground penetrating radar.
Wait, but what's feasible GPR?
It's a GPR that can either be attached to a drone or a rover based on the user's requirement. And it's not just that, we are integrating 3 things in it.
So basically, we are incorporating machine learning model to our GPR, which increases the graph analysis, and we believe surely that it will increase the prediction of the underground object, whether it's human or not.
The second thing we are integrating is the map integration. So basically, we are integrating maps to exactly pinpoint the location of the victim, both latitudinally and longitudinally.
For the last integration of our project, we would be integrating a drone as well as a rover in the same chassis, and we would be introducing it as a hybrid GPR.
Now we would like to introduce you to our hybrid GPR, which is called the Search and Rescue Vehicle and will be referred to as SAR-V.
What do you think of this collaboration?
I think it's really cool, but why are we integrating them?
During rescue operation, even if the rover fails due to toppling, our drone takes over the operation, and we are sure that the rescue operation doesn't halt anywhere in the middle.
In this section, I will walk you through the architecture diagram of this project. SAR-V, which is the Search and Rescue Vehicle, has 3 main components in it: the drone, the rover, and the GPR. The drone and rover are for operational purposes, but the data collection happens through GPR. The GPR's main component is the microprocessor, for which we are opting for Arduino in our prototype. The microprocessor will be connected to a transmitter and a receiver, and these together will be connected to an antenna through which the signals will be transmitted and received. The EM waves from the GPR travels through the ground, and when it gets in contact with an object, it reflects back. These reflected signals, which will be in the form of analog, will go through the data digitalization and graphing process for digital conversion. Using this, the ML model will plot a datagram, which will be the input for the deep learning model. For the deep learning model, we are using the convolutional neural network, where the data filtering and noise cancellation happens, leading us to the feature extraction. A steep parabola in the datagram with a positive pulse having a strong signal means that the object underground is a human. The positive pulse is due to the high dielectric of the humans, which is relatively high due to the moisture content in us. On the basis of the dielectric factor, the deep learning model predicts if the object underground is human or not. This prediction, along with the live GPS location of the SAR-V and the live camera footage, will be displayed in our Android application software in real time. If the object underground is a human, then the location coordinates and the ground view will be sent to the NDRF team for rescue operations. If the prediction is false, then the device will move for further search. The data collected from SAR-V will be stored after being encrypted if the internet connection is available. If the internet connection is not available, the data will go to the ML model as an input, and the output data from here will be stored in the local host, which is the rugged tablet. Once the internet connection is back, the data will be efficiently stored in the database. Since the data we are dealing with is highly sensitive, it needs to be effectively protected. For that, we are collaborating with Certain for data encryption, and we are also collaborating with NCIIPC, which is a government organization for critical infrastructure protection. This way, we are ensuring maximum security for our data.
So, is that all, guys? Have you ever thought about the flight of the rescuer in operation?
Yeah, we have to consider about that. Do you have an idea?
How about we use remote control to control our SAR-V mission? That way we can also eliminate the presence of, human technicians in disaster spot. We can, ensure their safety.
Remote controls, but do you think remote controls would cover long range distances?
Yes, we can use a long-range router in order to connect our SAR-V mission with the long-range router.
Guys, devices like GPR already exist, so why would people buy our product?
Yeah, that's a good point. We have to consider about the feasibility of our project.
So, our project is technologically feasible because we are implementing rovers in it. The rovers basically reduces the manual efforts, and the rescuer has no need to get to the spot and risk his life to save other people's life. By this, we are also reducing the manual labor cost, and that makes our project technologically feasible.
Okay, now let's see how our project is feasible cost-wise. Our project VL360 not only focuses on the concept of victim rescuer, it can also be used in industries such as archaeology and infrastructure inspections. Coming up to the cost structure of our product SAR-V, it costs around 20 lakhs, in which we'll be spending amount of 13 lakhs for the components and a 50,000 for providing a rugged tablet and at 2.5 lakhs for the production charges. Moreover, we consume a profit of 4 lakhs per SAR-V. The system Victim Locator 360 integrates several key components to enhance situational awareness and decision-making capabilities for rescue teams. The video to the left is the view of a human. The application VL360 features a split-screen interface. On the bottom right side of the application screen, users can view the 360-degree view live stream, enabling them to virtually teleport to the disaster site. The left side of the application screen displays a graph analysis of sensor data collected by the SAR-V. A machine learning algorithm processes the sensor data in real time, looking for patterns and anomalies that may indicate the presence of trapped victims. When the algorithm detects a high probability of a human being trapped under debris, it triggers an alert on the VL360 interface. This alert is displayed as a green checkmark symbol. In addition to the sensor data analysis, the VL360 application also integrates GPS tracking of the SAR-V. The system aims to improve the speed, accuracy, and effectiveness of disaster response operations.
We really believe that our product would be a game changer in victim rescue so that the Wayanad tragedies doesn't happen again.
If this project comes to realize in action, it would save many lives as possible.
We believe that we have explained our project clearly. Thank you. This is Team Codified signing off.